Hey guys, so we're down here in the lab where we're doing demonstrations and lessons around a whole number of different topics, and we've been learning a little chemistry. Specifically, we've been learning how the atoms of elements bond together to get particles called molecules, and we need molecules to form these new materials called compounds. So today we're going to perform a kind of exciting chemical reaction. We're going to take the element magnesium. I've got some right here. I've got this magnesium, this metal magnesium in the form of this ribbon. It's kind of a gray, silver, brittle metal. And we're going to combine that with oxygen gas from the air. And we're going to use a little heat. You can probably hear the torch going on in the background over here. There it is, okay? And we're going to need that heat, and we're going to heat up the magnesium. It's going to react with the oxygen, and it's going to form a compound called magnesium oxide. So I'm going to stop it here and get ready, and we're going to do the reaction. We're ready to do our chemical reaction now with the magnesium ribbon, and we're going to put it in the torch here. We're going to heat it up. I've got my safety goggles on, and oh, look at that. Unbelievable. Look at that brilliant light that's being given off. The magnesium ribbon is now combining with oxygen and changing to magnesium oxide. Unbelievable. I can't even see right now. The light is so bright. And now you know where. I'm going to turn this torch off here. All right, and let's take a look at what we have. And all that light that was given off. Now you know what's used in fireworks and flares and things to get that brilliant light. Look at what we have here. We no longer have magnesium. We no longer have oxygen. What we have here is a compound called magnesium oxide, this white powder. Okay, this is a compound. It does not have the properties of magnesium anymore. It's nothing like this magnesium ribbon, and it's nothing like oxygen, obviously, because it isn't. It's now magnesium oxide. So we're going to go to the whiteboard, and we're going to break this down and figure out exactly what happened here and look at what's going on with the atoms to form molecules of magnesium oxide to make this white powder. Okay? All right, so I'm going to stop the video here, and we're going to come back. Okay, so we just saw a chemical reaction where we took this metal, magnesium, the element magnesium, magnesium atoms, we combined it with oxygen atoms from the air to get this white powder, magnesium oxide. A lot of light was given off. It was pretty exciting, and now we want to try to see exactly what was going on at the atomic level and at the molecular level. So we're going to go to the chart that we have here, the whiteboard that we have in the lab down here. Okay, let me just get the camera set up here. All right, good, we're good to go. So we're going to start by diagramming a magnesium atom. So I'm going to put a circle here to represent the nucleus. I'm going to put Mg. That is an M, okay. Mg for magnesium. And magnesium has an atomic number of 12 protons. This means it also has 12 electrons. We'll get to that in a minute. All right, its atomic mass is 24. So I want to put the neutrons in here too. I'm just going to put N for neutrons. 12 neutral neutrons, which hold these 12 positively charged protons together because they would push each other apart because they have like charges. All right, now let's get to the electrons. We have seen that electrons in atoms are not just scattered randomly. They are in specific energy levels. And of course this is not to scale, but this is just for diagrammatic purposes and just so we can understand what's going on here. So we have the Bohr model here. All right, 12 protons means we have 12 electrons. They are arranged in specific shells. The first shell can only hold 2 electrons, 10 left. The next shell can only hold 8. 1, 2, 3, 4, 5, 6, 7, 8 electrons in shell number 2. I'm up to 10. Now the outside shell, or valence shell as it's called, has 2 electrons in it. Now what's magnesium looking to do? Like all atoms, they're looking to have a complete outside shell of electrons. It's not going to be trying to get 6 electrons to complete this outside shell with 8. They're always looking for 8. That's the octet rule. However, all right, it's easier if magnesium, like all metals, what they do is they just look to lose these 2. If they lose these 2 electrons, it will now have a complete outside shell with 8. But it just can't lose them, just give them up. It needs atoms that will take them. So we're going to bring an oxygen atom in here because that's what we saw in this reaction. So I'm going to draw an oxygen nucleus, slightly smaller. Oxygen, oxygen, has 8 protons. It has 8 neutrons. How do I know this? Because the periodic table says it has an atomic number of 8. That means 8 protons. It also means I have 8 electrons. It has an atomic mass of 16. That means it has 8 protons, 8 neutrons for a total mass of 16. All right, now, that's the mass of the nucleus. Remember, the electrons don't have any mass. All right, essentially, 8 protons means I have 8 electrons, which means 2 in the first shell, and then how many are going to be in the second shell? Well, there will be 6. 1, 2, 3, 4, 5, 6. But is oxygen happy? All right, no, because it wants to have a complete outside shell of electrons. It's neutral, but it isn't happy. So oxygen wants 2 electrons. Magnesium is looking to get rid of 2 electrons, so this works out perfectly. So magnesium is going to give its electrons over here to oxygen. Oxygen will now have 8 in its outside shell. It is no longer neutral though, but that's okay. It has a complete outer shell, which is what it is looking to have. If it has 2 extra negative charges, it is now going to have a net charge of -2. This is no longer a neutral atom. This is what we call an ion, a charged atom. It's still an atom, it's just got a charge to it. Magnesium just lost 2 electrons to oxygen, and it's happy now. It's got an outside shell of 8, but now it only has, since it gave up its 2 electrons, now it only has 10 electrons, but it has 12 protons. 10 electrons, 10 negative charged electrons, 12 protons, which means it has a net charge, an overall charge of +2. It is no longer neutral either, all right? But it's got a complete outer shell of electrons, so it's happy, but it's not neutral. So what's going to happen here is the positive charge magnesium, the negative charged ion of oxygen, because it just got its electrons from magnesium atoms, are going to join together. Opposite charges attract, and this is what's holding together the oxygen atom and the magnesium atoms. We put this pen down here. The magnesium atom and oxygen atom are joined together because they are now charged particles. They are charged ions. Negative ion is attracted to the positive magnesium ion here. And now we have a magnesium oxide molecule. And the ratio is 1:1. 1 magnesium for every oxygen. Why? Because magnesium is looking to get rid of 2 electrons, and oxygen is just looking for 2. So this works out perfectly, a nice 1:1 ratio. So the chemical formula for this molecule is MgO, which means 1 atom of magnesium and 1 atom of oxygen. The molecule is neutral. The molecule is neutral, the atoms are not. And that's kind of cool. So they're happy, they've got their outside shells are complete, and at the same time they've been able to maintain neutrality by forming this molecule. Now another thing I want to say is this. The electrons got exchanged between magnesium atoms and oxygen atoms here. What we saw in this reaction was a tremendous amount of light that was being given off, a tremendous amount. Where did that light come from? Where the light came from was the electrons moving. The electrons moving from this energy state to that energy state. It's actually going to a lower energy level. This is actually a higher energy level. It's further away from a nucleus to a lower energy level, closer to a nucleus. And whenever electrons do that, they give up energy, and that energy came off in the form of light. And there were trillions and trillions and trillions of magnesium atoms giving their electrons to trillions and trillions of oxygen atoms. And in that process, they were jumping down to a lower energy level and releasing a tremendous amount of light. And that's where all that light came from, and we saw in the reaction. So to summarize all of this, let's just put it all together very quickly. We took magnesium atoms and oxygen molecules with heat, and we made magnesium oxide molecules. Oxygen in the air is O2 molecules. That's how it exists. It's not individual oxygen atoms. Magnesium and oxygen are known as the reactants in this reaction, because they're the elements reacting, and the product is magnesium oxide. That is known as the product in a chemical reaction. And this is what the reactants are on the left, the product is on the right. We have an arrow indicating, it's like an equal sign, that this plus this equals that. And sometimes at the arrow, we have some sort of designation of what is being used to make this reaction happen. It's interesting that this reaction would not happen without the heat that we gave it with the torch. So this sort of summarizes the chemical reaction as well. So let's just take one more look at what happened here today. And we took magnesium ribbon, and we added heat, and we turned it into this white powder. It's a compound, magnesium oxide. I gotta tell you, this is what's magical about chemistry. This white powder is nothing like the magnesium from which it came, which is weird because there are magnesium atoms in here. It's nothing like oxygen either, which is weird too because it's got oxygen atoms in there. But here's the deal. The reason why this has totally different properties than either magnesium or oxygen is because it's no longer magnesium atoms and it's no longer oxygen atoms. It's magnesium oxide molecules.